Hi, good morning, good afternoon. We're gonna start with Pure 4. I've decided to start with chapter 2 first because for Friday afternoon, and chapter 1 is a bit of a funky one. I think I need more time to prepare it. And this is a bit of a recap of something we've done before. So chapter 2 is all partial fractions. So some of it is a repetition of what you did in Pure 2, I believe. And we're just going to explore a little bit further, a couple more things. But I think what I'm going to do is split this chapter into 3 quick videos, each one exploring one of the 3 key different aspects of the chapter, but it's not difficult. You will see it's a bit of algebra manipulation. So let's refresh our minds. Let's take a trip back to Pure 2. I've got that fraction there, 5 over x plus 1, x minus 4. And they tell us that it can be rewritten into partial fractions. I can split it up. So how do we go about it? How do we find the values of a and b? So, well, all I'm going to do is basically take that a over x plus 1 and b over x minus 4, and I am just going to add those 2 fractions together. I'm going to put them with a common denominator. So left hand side is going to stay as it is. And the right hand side, well, the common denominator I know is going to be x plus 1, x minus 4. We know that. And then I will have to multiply times x minus 4, and b I will have to multiply times x plus 1. This shouldn't be a surprise to anyone, this shouldn't be a shock. We've done this plenty of times before. And now, because both sides have got the same denominator, I can basically multiply both sides by the common denominator, be rid of it, and what I've got is 5 is equal to a times x minus 4 plus b times x plus 1. Once you reach this point here, you got 2 options. You can either substitute different values of x in there, any values you get to think about in order to find a and b, or you could equate coefficients. There's 2 ways to go about it. The easiest thing, I suppose, is to substitute values. Now, which values of x am I going to substitute in there? You could choose any. You could pick any 2 values of x, and you would end up with a couple of simultaneous equations in a and b that you can solve. But if you pay a little bit of care and attention, I am going to choose the values that make those brackets 0. That's going to speed up the process. Any 2 values would do, but the ones that make the brackets 0 are going to speed up the process. So if I substitute x equals 4 in this expression, this bracket will become a 0, and what I've got is that 5 equals x is 5b. Therefore, it's clear to see that b is 1. And the other value I was going to substitute would be x equals minus 1. So back in this expression here, so this is my star expression. If I substitute x equals minus 1, in here I've got that 5 equals minus 1 minus 4 is minus 5, so minus 5a, and minus 1 plus 1 is 0, all of that turns into a 0, therefore a equals minus 1. And I finish. So the 2 values a and b I was looking for are there. This is it. Very quick recap. I'm going to do one more example, perhaps a little bit trickier, but that's going to be it for now. And here we are with the second example, which, if you refresh your minds, you should be able to remember from way back whenever we did this. So here we go, another algebraic fraction, 6x minus 2 over x minus 3x plus 1 can be written in that form. So we're going to do exactly the same thing we did before. We're just going to add the 2 fractions on the right hand side of the equation. We're going to then get rid of the denominators and see what happens. So 6x minus 2 over x minus 3 x plus 1 is equal to a x plus 1 plus b x minus 3 over x minus 3 x plus 1. And those two sides are equal to each other because they told us. We just tied it up and rearranged a little bit. So now that denominator and that denominator, I can multiply both sides by the same thing, so they will cancel out. So I've got that 6x minus 2 is going to equal a x plus 1 plus b x minus 3. Remember, this is my star equation where I'm going to be doing the substitutions and figuring things out. I could expand the brackets out and try to equate coefficients, and I will end up with simultaneous equations which I can solve, or I could just substitute numbers. Maybe this time I'm going to do both to show you how both methods work and give you the same thing. Substitution, I could do the same thing, just substitute any two numbers, end up with simultaneous equations, find a and b. But because we're intelligent people, the easiest two numbers to substitute in there are going to be minus 1 and 3. So if we start with minus 1, if I substitute x equals minus 1 in the equation, I get minus 6 minus 2 is minus 8 equals, all of that is 0, minus 4b, therefore b equals 2, because minus 8 divided by minus 4 is 2. Right, and if I go back to my star equation there and I substitute now x equals 3 in there, I get 18 minus 2, 16 equals 4a plus nothing, so from there a equals 4, and that's it, I'm done, I've finished. Okay, so that's how we find a and b by substitution. Like I said before, we could do it by equating coefficients, and how that works is as follows. I'm going to take my star equation, and 6x minus 2 is going to equal ax plus bx plus a minus 3b. All I have done is expand the brackets and just rearrange the terms in the expression like that. And what you can see is that a plus b has to be 6, because those are the two coefficients of x, and ax plus bx has to be 6. So that's that. And then a minus 3b has to be minus 2. So minus 2 equals a minus 3b. So here I've got a pair of simultaneous equations that I have to solve, and all I'm going to do is take them away from each other. So if I take away the simultaneous equations, I get 8 equals 4b. So b equals 2, which is what we had earlier. So b equals 2. And if b equals 2, a must be 4. There you go, done, sorted. This is it. This is just a recap of what the PO2 partial fractions is, and that's the first bit, what you need to do today. Excellent, let's get going.